Now it's recording. So y equals j50, and z is 1 over y. So to get the z value for the capacitor is going to be 1 over that, and to get rid of that j, we'll multiply the top and the bottom by j. So you have j squared in the bottom, 0.050. Well, j squared happens to be a negative 1, so it's negative j over 0.050, and that number will be what? Huh. I just used it. The battery's dead, I think. I just checked it. Okay. I got another one. I just used it before I came up here. Tested. 1 divided by 0.050, that's negative 20j. Now, y for the inductor? J25 milli. That should be negative. That should be a negative 20, negative j. Did I write? Did I copy it wrong? Yeah, it's negative. Yep. So z for the inductor has to be 1 over y of the inductor, which is 1 over negative j 25 milli, which is 0.025. I knew it was going to be negative because the value has to be positive at the end. So I'm going to multiply the top and the bottom by j. Oh, j not j squared. It's going to end up being j squared. So that's going to be ZL is going to be j over negative j squared 0.025. And j squared is a minus 1, so what's a minus 1? That's a plus 1. One divided by 0.025, which is 40j. And the last one, again, this is y for the resistor, which is 40 milli. Z for the resistor is going to be 1 over 40 milli, 0.040. 1 divided by 0.040, and that's 25 ohms. So if you want to turn them back to Z's or impedances instead of admittance, that's what you have. So now I can redraw the circuit with numbers I'm used to. I go, this is 20 milli. That means 0.02. Instead of 20, I'm going to go 0.02, angle 0. A capacitor of the value, what was the value of the capacitor? Negative 20j. An inductor of the value of what? 40j, positive here. A resistor of 25, and now I have a current source going that direction with the value of 0.05 angle negative 90. What was the question here? Use nodal analysis to find what? V1, V2. So this is V1, and this is V2. I can assign current any direction I want to. Label that I1, I2, I3. KCL at V1. KCL at V1. The current in equals the current out. What is going in? 0.02 angle 0. Angle 0 means just 0.02. You don't have to put the angle. What's leaving? I1 plus I2 plus 0.05 angle negative 90. If you really want to think about your complex numbers, this is, oh, this is a nice sheet of paper with stuff on it. Complex numbers. This is the real, this is the imaginary. The first one, 0.02 angle 0, that means it's a vector in this direction. So it's all real. That's why I said 0.02 angle 0. You can write that just 0.02. This one, 0.05 angle negative 90, which is where? Down this way. That's 0.05 angle negative 90. Since that's the imaginary and it's coming down, it's really a negative 0.05 j. It's in the negative j direction. So a lot of times you see me take the negative 90, make it negative j. If it's plus 90, I write that as plus j. If it's 180, that's in this direction, I just change the sign to a negative value. So if I have 4 angle 180, I go, oh, that's the same as negative 4. Because that's pointing in this direction. Real value only. If I have 7 angle 90 degrees, that's 7 units up pointing in that direction. That's what? 7j. If I have 6 angle negative 90 degrees, that's pointing down. That's negative 6j. If I have 13 angle 0, a lot of times you see me just write 13 because it's in the real value. There's no imaginary. Complex numbers in rectangular is alpha plus j beta when you write them in rectangular mode. When you put them in polar mode, that what you're seeing here, r, the angle theta, r is going to be the square root of alpha squared plus beta squared, and theta is going to be the inverse tangent of beta over alpha. So I can go back and forth between them. So when I have value like 4 angle negative 9, again, if you think about it, what that means, if you want to change it to rectangular, 6 cosine 180 plus j 6 sine 180. What is sine 180? 0. So that says 0. What's cosine 180? Negative 1. That's why it's a negative 6. When it's 180, it becomes a minus sign. When you get 3 angle 90, to change it to rectangular, I know that's 3j, but if you don't believe me, that's what? 3 cosine 90 plus j 3 sine of 90. Cosine of 90 is 0 times 3, that's 0. Sine of 90 is 1 times 3, that's 3j. Just things to remember, because I do that a lot. I take this, I go, that's 0.05 negative 90 degrees. That's 0.02, just real value. Because what I'm doing, I'm changing it using this rule that if you have a polar, r angle theta, you can change it to rectangular by going r cosine theta plus j r sine theta. That's the rule I'm using to convert them. Just heads up on that one. I didn't mean to sneak that in the middle of this problem, but I just want to make sure because I do that a lot. So now if I do that, that'll be 0.05 angle negative 90. Again, this is negative 5J. This is 0.02. When I bring this to this side, I have 0.02 plus, that becomes a plus 0.05, because that's a negative J. When you bring it to this side, change sign, becomes plus J. Equals I1. What's I1? V1 minus V2 over 40J plus I sub 2, which is V1 minus 0 over negative 20J. Another thing you're going to learn quickly, I'll put it that with that rule. If you have J in the bottom, I'll give you an example. A over anything with J in it in the bottom. That becomes, you can take the J from the bottom, move it to the top, make it negative A times J. Why? Here's the math behind it. To get rid of that J, we're going to multiply the top and the bottom by J. That's AJ in the top. And what's in the bottom? J squared. And what's J squared? Minus 1. So if you have a positive J in the bottom, when you bring it to the top, it becomes a negative J. The same thing. If you have a negative J in the bottom, when you bring it up, it becomes a positive J. Again, why? You multiply the top and the bottom by J. J squared is minus 1. With the minus sign, is going to make it a plus 1. So you'll see me when trying to find the LCD and all that. I might play with it and go, wait a minute. You might say, see that J in the bottom? I'll bring it to the top, becomes a negative J. That'll be negative J. That's a negative J in the bottom. Bring it to the top, becomes a plus J. And what's my LCD now? Isn't that a 40? Multiply by 40. 0.02 times 40 is that 0.8. 0.05 times 40 plus 2J equals negative J times V1 minus V2 plus 2J times V1. Clean that. For V1, what do we have? 2J and minus J will make it what? Plus J? And this is plus JV2. That's the first equation. Now let me go right there and do another KCL at V2. Current in equals current out. Current in, 0.05 negative 90. Can you see it on the top? Yep. What else? I sub 1, what's leaving? I sub 3. This is negative 0.05 j. Negative 90 is negative j. Plus I sub 1, which is V1 minus V2 over 40j, equals I sub 3, which is V2 minus nothing over 25. I can take the j to the top, make it a negative j, minus j times V1 minus V2 over 40 equals V2 over 25. 40 and 25, what's the LCD? 200, is it? I think 200. So if I take this equation, multiply it by 200 to get rid of the fractions, (200) times 0.05, that's negative 10j. 200 divided by 40 is 5, I think. Negative 5j V1 minus V2 equals 8V2. Clean it. Negative 10j equals. When I take this one to this side, it becomes a plus 5j. Plus, so V1 will be 5j V1 plus 8 minus 5j V2. And now that's my second equation. I have two equations by two unknowns. Equation 1, equation 2. Take the two equations, solve them any way you want to. You can use substitution, elimination method, or if your calculator does that, let's see this one. The other one, here we go. I'm going to tell them I have two equations by two unknowns. I have simultaneous on mine. Number of equations 2. And I'm going to put the coefficient. So this one, this is 1j. So the way you write that, complex number 0 on this calculator, 0, comma 1. The real portion is 0. The imaginary portion is 1. B1, it's a complex number 0, comma 1, 2. Answer 0.8, comma 2. Equation 2 now. 5j, 0, comma 5. 8 minus 5j, 8, comma, negative 5. And the last one is the answer, which is 0 minus 10. 0, comma, negative 10. Solve. And here's x1 and x2. That's v1, v2. So v1 has complex value. It's 1.062 roughly. Angle 23.3. V2, I left a space there so I can convert that to a time domain. 1.593. Angle negative 49, negative 50 roughly. Well, actually, I can't convert them because the problem was given to us in Phasor. 1.062, angle 23.3, 1.593, negative 50, on the money. So to answer your question, yes, you can write the coefficient complex and it will do them for you. TI-86, TI-89, all of them, you know. Any other questions? Let me try another problem. Let me stop here.